We'll now do a recap of what we did. So we say that the position was x and the units was meters. The displacement is delta x, which is x final minus x initial, and the units are also meters. The average velocity is delta x over delta t, and the units are meters per second. The instantaneous velocity is in the limit when delta t tends to 0 of delta x over delta t, so that becomes dx over dt. And the average acceleration is delta v over delta t, which is v final minus v initial over delta t, and the units would be meters per second square, so it's meters per second also. And the instantaneous acceleration is going to be the limit when delta t tends to 0 over delta t, which is dv by dt. Now, from here, we can see that since v is dx over dt, therefore x is the integral of v dt, and the limits would be from t initial to t final. And similarly, here the acceleration is dv by dt, and therefore v is the integral of a dt. So if we're given a, which may even be variable, then we can get the velocity by integrating this, and we integrate the velocity to get the position. Now we'll now build up some equations that would relate the acceleration to the velocity, the displacement, position, and time. Going to our first equation, v average is delta x over delta t, which means x final minus x initial over delta t. Now remember, whenever we write delta anything, it's always that thing final minus the initial. So if this is delta x, it's going to be x final minus x initial. If it's delta v, it's going to be v final minus v initial. Whatever the delta, it's always the final minus initial. The delta t would also be t final minus t initial. Now with this equation, we can rearrange this equation and say x final minus x initial over delta t equals v average. Just bring this on the left and the other thing on the right, and then cross multiply with delta t, so we get x final minus x initial equals v average delta t, and therefore x final is x initial plus v average delta t, and that becomes an equation of motion. So if we know the average velocity and the time and the initial position, we can find the final position. For constant acceleration, which is what we are going to consider, v average is given as v initial plus v final over 2. So if an object starts from here and it's moving with the velocity v initial, and then at this point it's moving with the faster velocity v final, then the average is simply the sum of the two divided by 2. Okay, so that is, but only if a is constant. Now let's look at another equation. We have a average is delta v over delta t, which is v final minus v initial over delta t, and by what we did for the position, we can get at v final equals, we cross multiply, becomes a delta t, and therefore v final equals v initial plus a delta t. Now we need not write average because we are considering constant acceleration, so the average is always equal to the instantaneous. And so we have our second equation, that v final equals v initial plus a delta t. And this was the first equation. This is the second equation. The next equation we get from here, from the first equation and from the second and from this v average. So we can write x final equals x initial plus v average delta t. The v average is vi plus vf over 2, so we replace that here. xi plus vi plus v final over 2 delta t, which becomes x initial plus vi by 2 plus v and delta t, v final over 2 delta t. And now we had that equation, v final equals v initial plus at, so we replace that over here. Becomes x initial plus vi over 2 delta t. X final becomes vi plus a delta t. That's the replacement for v initial delta t, and that becomes vi by 2 delta t. Just write it once again. The vi delta t by 2 becomes another vi delta t by 2, and this becomes a delta t, and delta t become delta t square over 2. So it becomes xi. So these two are the same thing, divide by 2, divide by 2, so they become vi delta t plus half a delta t square. That becomes our next equation, which we can also write the delta t being t final minus t initial. If t initial is taken as 0, then delta t is simply t final. So we normally write this equation as x final equals x initial plus vit, t being assumed to be t final, half a t square. So that's our next equation. Becomes the third equation. Okay, starting off with v final equals v initial plus at, we get t equals v final minus vi over a. And we look at the second equation, xf equals xi plus v average t, and v average is v initial plus v final over 2, and we use the t from here to substitute here, so that becomes over a. That becomes xi. We can take the 2a outside, and now it's vi vf and vi square and plus vf square and a minus vf vi. Now these two would cancel out, and we would have xi plus v final square minus v initial square over 2a is xf, which we can rearrange to write it as x final minus x initial times 2a equals vf square minus vi square, and that becomes vf square equals vi square, take it on the other side, plus 2a delta x, and that becomes our last equation. So to summarize, we have the following equations. we have V final equals V initial plus AT, where T is the T final. We have V average is V initial plus V final over 2. X final equals X initial plus V initial T plus half A T squared. We can also have XF equals XI plus V average T, and we have VF square equals VI square plus 2A delta X. So we have these 5 equations, but the one that we're going to be most often concerned with are going to be these 3.